Okay, so we're going to be looking at quadratic equations and the general form of them and an introduction to quadratic equations before a series of other videos where I'll talk about the specific skills you'll need to apply. A quadratic equation is one that involves an x squared term, so in this case ax squared, and it can have an x term and a number term in it as well. What we're going to look at is first of all the shape of it. So if you just first of all take the most straightforward of the quadratic equations, which is just y equals x squared, and if x was 0 then y would be 0, if x was 1 y would be 1, if x was 2 y would be 4, and so on. And what that does is it creates a curve like this. Ignore the fact it's not quite as wobbly in real life. Now this is called a parabola. And with quadratics, which form a shape of a parabola, there are some key points that we need to identify on them. Those key points are, and imagine that the parabola can move anywhere. As you change the equation, you might get an equation there or there or there, or the graph will move around. Similarly, if it was a minus x squared, then you'd find that the shape would turn upside down, and that would be a y equals negative x squared. Now, if I just turn it back to how we had it before, for a positive x squared, as I said, it could move around. Now if you imagine that I've got this particular equation here and there are some key points on it. The first and easiest to find is this point here, the y-intercept. And if you're familiar with linear equations, which you should be, then you'll know that the y-intercept is just purely the number term in y equals mx plus c, and it's no different here. That is the y-intercept. And the reason for that is that any point on the y-axis is going to have a coordinate of 0 and then whatever the y value is, in this case c. And if x is 0, then that term will be 0, that term will be 0, and therefore you have y equals c when x is 0, giving you your y-intercept, the number term in a quadratic equation. The next set of points you need to be able to find are these 2 points where the curve crosses the x-axis. Now these are known as solutions, so if you have to solve a quadratic, these are the 2 points you're looking for, or sometimes you might hear them referred to as roots. Either way, the x value where the curve crosses the x-axis is a very important point for quadratics. So if we needed to solve them, we need to find these 2 points here. Now at these points, at the x-axis, y equals 0. So to solve a quadratic, it's got to be of the form ax squared plus bx plus c equals 0. And you can only solve when y is equal to 0. And there'll be another video where you can have a look at how we do that. The final point you need to be aware of is this point here, which in this case, because we've got a positive quadratic, a parabola in this shape, then this is the minimum. And it can be quite useful to find it. Obviously, if it was minus x squared and the graph was the other way up, like I showed you before, then it'd be a maximum. And this can be found by completing the square. Again, there is a video on that particular skill. Now the main task you'll be given in most quadratic questions is solving. So just to recap, if you're going to solve a quadratic and find these roots where the curve crosses the x-axis, you're going to be looking to either factorize, which I'll go into in another video. You might use the quadratic formula, which there'll be a video following this one, and you could also solve by completing the square. And again, we'll have a look at how to do that in another video.